Hi guys, and welcome to this my video on perimeter and area. Now I'm going to say it's for the general Maths 1-2 course in Australia, but pretty much perimeter and area is in Maths from about year 4. And we're just going to recap it because it is important. Now my name is Darren from Maths Guru. Thank you very much for watching. If you can do me the honor of signing up to my YouTube channel, that would be greatly appreciated. Maths Guru is out there. It just lets me know that people are watching. Terribly sad and needy. Nobody out there watches maths videos, and every now and again I go, oh, I can't do this anymore, no one watches my videos, and then every now and again people go, no, please, I'm watching your videos. If you can tell your teachers and your friends and whatever else, that would be also appreciated. Mathsguru.com is there for downloadable notes and videos, and it all maps to Cambridge, and it's all there for you as well. Now, normally I would go through the learning objectives, but feedback was, why? We can read. Okay then, it's there. Now, all the stuff behind me, you can see it actually right all over. You can download as well. Now, this is the next part in the Year 11 General Maths course, looking at measurement scale and similarity. All right, so I'm basically recording all of Chapter 10 as it currently stands in the Cambridge General 1-2 book. And thank you, Cambridge, for allowing me to use your worked examples. You guys absolutely rock. Thank you, thank you, thank you. In the previous two videos, we looked at rounding and Pythagoras' theorem. My Pythag video is probably the best one I've done today. Go and watch it. Go on, no, it's really, really good. Almost funny. He says, thinking he's funny, and other people tell me I'm not funny. But anyway, all right, we're now going to look at perimeters and areas of common shapes because measurement is important. Now, I live in Melbourne, and when I first started walking past that rather impressive building you can see here, I was like, oh, that looks pretty funky. I wonder what type of hotel that is. It's not a hotel. It's a prison. Smack bang in the middle of the CBD. Not at all concerning. Yeah? I mean, obviously, if there is a prison escape and I'm anywhere near, we are no. Yeah? All I'll probably do is stand and cry if anybody actually escapes. But, whole new discussion. There is a prison. Now, what keeps people in prison, other than the wish to do better in life, is basically a perimeter fence, and thank you very much for that, because perimeter fences are basically fences what go all around the outside, and so that's how I remember perimeter. It is a way of starting at one corner, walking all the way around the end, or the edges, and ending up where we started, and if I had my step counter on it, or what have you, I'd be able to measure how far that was. So perimeter, how far around the edge. Now, with maths being maths and Barry being Barry, what do you mean you don't know about Barry? Don't worry about it. He's tried to make this difficult. And we use these strange little symbols on some of our diagrams. And why do we use these strange little symbols? Well, basically, they are there to try and help you know what side lengths are the same. So, because this has one little mark, and that has one little mark, it means that that length there and that length there are exactly the same. So normally, I would now write the length on there, and I'd say 12. And what about the two little marks? That doesn't mean it's twice as long as 12, although that would be funny. But anyway, those two little marks mean that these two sides are the same length. So everywhere that has two little marks on, I'm going to write 16. And now, believe it or not, I have everything I need for the perimeter of this shape. Because I could start here, do 25 plus 12 plus 16 plus 16 plus 12, and back from where I started, or back to where I started, and ka-ching, I'd be able to add all of those together. So basically, these things are trying to trick you. Now, I'm going to try and trick you again with this one, because I love these questions, he says rather sadistically. Here's another example. Can you find the perimeter? Do they give you enough information? Well, I know this length here is 6, and I know that length there is 8. I don't know that length. But hold on a moment, I could work it out, because I know that length there is 6, and that length there is 2, and 6 take away 2 would give me 4. Aha! We know that that length there is 3, that total length there is 8. What would this one be? Well, that length there and that length there must add to give me 8, so that would give me 5. And in what I'm saying, I'm actually almost giving you the hints to how I'm trying to trick you, or how the question's tricking you. Now, obviously, if I wanted to work out the perimeter of this shape, I would go 8 plus 6 plus 5 plus 2 plus 3 plus 4. That's certainly one way of doing it, but there is such a quicker way of doing it. And what I want you to do is imagine that I'm now going to push this 3 centimeters up. Right? I'm going to push that 3 centimeters up until it gets to the edge of my shape. So there we go. So that's my 3 centimeter line connected to this line. Hold on a moment. All right, now I'm going to do this 2 centimeter line. I'm going to push it out. Because it's not going to stop it being that long. It's still going to be 2 centimeters regardless of where it is on my shape. But here, hold on. There's my 2 centimeters. Well, I've now just created a rectangle. And I happen to know that this length here is 8. And that length there is 8. This length here is 6. And that length there must be 6. Oh my goodness, I could have saved myself so much time. Because when I push these out, they still make the rectangle. So basically, my perimeter in that situation would be 8 plus 6 plus 8 plus 6. Which is going to be what? That 14, 28 centimeters. Or I could have done 6 times plus 8 times 2. Da, da, da. So again, there are tricks to some of these questions. Now, there are areas of shapes, rectangles, and parallelograms that you will need to know. And thank you, Cambridge, for coming up with all of these sort of boxes and stuff with formulas. I'd slam in your summary book. Download these notes if you need to. Put them in there, put them in here. Now, I don't like this whole A equals LW and A equals BH rubbish, to be honest with you. I like to think of a rectangle as having, he says, where's his hands for the camera, of having basically 2 lines connected by a right angle. All right, so I always tell people for a rectangle to find 2 lines connected by a rectangle, and they are the ones you multiply together. The reason being is lots of people get very, very tricked. So I could write 4, 6, 4 and 6 on there, and the people get confused because they think, oh, well, I'm just going to do 4 times 6 times 4 times 6, because they get perimeter and area mixed up. And again, I just say, no, choose the right angle, choose the 2 sides that connect the right angle, and there we go, we're done. And interestingly, that also works with a parallelogram. Again, I don't like this BH business, right? Because base and heights change depending on the orientation of the shape. So again, what I tell my guys to do is find the 2 measurements that are connected by the right angle, and those are the 2 you're going to multiply together. So that and that are connected by my right angle. And again, that's for rectangles and parallelograms. Then we get to trapeziums. Now again, this half A plus B times H business. It's such a shame I don't have enough room here, but I say add the parallels, times by how far apart they are, and divide by 2. So I always add the parallels, times by how far apart they are, and divide by 2. And again, if I want to know how far apart they are, I'm looking for the right angle. That's how far apart they are. Right, so in this situation, if I was going to work out my area of this side here and that side there are parallel. How do you know they're parallel? Because they've got those 2 little arcs there. But again, so many people get tricked by common shapes. If I wanted to work out the area of that shape there, all right, and I'm going to do this and this here, a lot of people go, oh, I'll split that into a rectangle and a triangle and I'll do composite shapes. No, why would you? That's a trapezium. We're just trying to trick you. Even though it's got a right angle here, it's still a trapezium. A trapezium is a quadrilateral with 2 parallel sides. So again, in this situation, I would simply add that. I would add that together. So those 2 I would add together. I'd multiply by how far apart they're going because the right angle is telling me that. And then I would simply divide my answer by 2. And what have we got here? Triangles. Now, triangles, half base times height. Again, what do we notice? I say to my boys or the students I'm teaching, look for the right angle, right? Base times height, and then divide it by 2. Now, the other one that's really, really important now is going to be this one called Heron's formula. Heron's formula says, if I'm given a non-right angle triangle, I think it probably works with a right angle triangle as well. But anyway, if I was given a right angle triangle, a triangle with 3 sides, and all I know is the sides, then basically we can use this formula here, where it tells me the area is equal to the square root of S times S minus A times S minus B times S minus C. And you're going to go, what is this S business? Well, as it says here, to find the value of S, you do A plus B plus C divided by 2, not 3. Lots of people make silly mistakes here by dividing by 3. And you're going to say, hold on, what is this A plus B plus C business? Oh, look, my triangle happens to have sides called A, B, C. So here, add the 3 side lengths together and divide by 2. Here, do the square root of that value of S, S minus the first side length, S minus the second side length, and S minus the third side length. So let's find the perimeter of a rectangle again. Be very, very careful with the wording here because it says perimeter. A lot of people get confused. So the perimeter is going to be that, plus that, plus that, plus that. Rightio. So my perimeter equals, don't forget to write P equals 12 plus 5 plus 12 plus 5. 17 times 2 is 34 centimeters. And because it's a length, perimeter is a length, it is just 34 centimeters. Find the area of the following triangle, giving your answer to 2 decimal places. All right. Oh, is this a right angle triangle? No. I mean, it might be, but probably not. All right. In fact, it's not, but that's a whole new discussion. Right. So right angle triangle. Note, what am I going to use here? I'm going to use Heron's formula. So Heron's formula says to find my value of S, do my 3 sides. So 3 plus 3.5 plus 5. And divide it by 2. All right, so I'm going to bring up my calculator, which is going to obscure that for a moment. And so what do we got here? We got 3 plus 3.5 plus 5. Hit enter. And I'm going to divide that by 2. It's going to be 5.75. 5.75. Turning that off. And it says that my area is equal to the square root of, I'm going to leave that for a moment, of S, which is 5.75, times S minus A. Now what it means is therefore do 5.75 minus your first length times 5.75 minus my second length, which was 3.5, times 5.75 minus my last length, which is 5. And now I'm going to draw my square root sign over it so that it knows. Now again, that looks really, really long. I know that. So again, firing up my calculator, and again, I'm using the TI Inspire. ClassPad guys, it's exactly the same for you guys. So I'm going to do the square root of, no, he says doing the image. Let's try that one again. I'm going to do the square root of 5.75. Try that one again. Times, open brackets, 5.75 minus 3, close brackets, open brackets, 5.75 minus 3.5. Close brackets, open brackets, 5.75 minus 5. And he's hit the wrong button there. Thank you for shouting at me. 5.75, 5.75 minus 3, 3.5 and 5. Hit enter, and there we go. So my area is going to be, correct, 2 decimal places, 5.17 centimeters and squared. And again, I've got a video on rounding to decimal places. It's really important in this whole course that you know how to round to decimal places. Find the area and perimeter in a practical problem. Oh my goodness, what is with these worded problems? Right, a display board for a classroom measures 150 by 90 centimeters. I always draw a sketch, 150 by 90, and let's put centimeters and centimeters. A, if ribbon costs 55 cents per meter, how much will it cost to add a ribbon border around the display board? Well, that to me is just a really long way of asking us to find the perimeter first and then work out how much it's going to cost. So for part A, my perimeter is going to be 150 plus 90 plus 150 plus 90, which is going to give me, fire up my calculator, 150 plus 90 plus 150 plus 90 gives me 480 centimeters. Now again, that's not the end of my answer because it says how much will it cost. Now we know for every meter it's going to cost 55 cents, but I don't have this in meters. How do I convert from centimeters to meters? I'm going to divide that by 100 to give me 4.8 meters. And then I'm going to times that by 0.55 because it costs 55 cents per meters. So let's do 4.8 times 0.55. Hit enter is going to cost me $2.64. So the cost, I'm going to get rid of that for the moment, is equal to 4.8 times 0.55, which equals $2.64. The display board is to be covered with yellow paper. What is the area to be covered? Oh, well, there we go. We've got to have area. This is a nice, easy question. Part B. So the area is going to give 150 times 90, which is going to give me, well, hold on a moment. There's a bit of a trick to this question because actually it says it wants it in meters squared. Now, when that's the case, my advice to you is always to turn your centimeter measurements into meter measurements. It is going to make life so much easier because then your answer is going to come out in meters squared. Right, so 150 centimeters is 1.5 meters, and 90 centimeters is 0.9 meters. And there we go. So if I now fire up my calculator and I do 1.5 times 0.9 is going to give me 1.35. So 1.35 square meters. If you tried, a lot of people do it the wrong way. I'm going to bring up my calculator, and a lot of people go, oh, that's okay, I'll do 150 times 90. And they get that. And then weirdly or strangely or incorrectly, they then divide it by 100. Now, all right, that's to go from centimeters to meters. If I want to go from let's go from meters to centimeters or centimeters to meters. I'm confused. If I want to do centimeter squared to meter squared, and this value here at the moment is centimeters squared, I would do 13500. I would divide it by 100. That's one dimension, but because we've got area is 2 dimensions, I would divide by another 100. And there we go, that gives me the 1.35 I was expecting. Just an explanation there, if you needed it. Composite shapes. What on earth are composite shapes? They are shapes which is what are made up of other more common shapes. So, in this situation here, if we take a look, if I was to put a dotted line along there, what 2 shapes have I got? I've got a nice and easy quadrilateral and then a nice and easy triangle. So in that situation, if I wanted to find the area, for example, I could, because I would find the area of the triangle, which is a half base times height. I'd find the area of this quadrilateral, and I would add them together. Likewise with perimeters, if I wanted to, if I knew the perimeter of all of these areas here, all of these lines here, I could do it. Now, a word of warning, a lot of people for some reason keep trying to add the distance on there. The perimeter is only on the outside. So start and walk around the outside and get back to where you started. I'm not going to walk through the middle here because that's not going to work, basically. All right, so there are lots of formulas out there that can help us do this. Right, a gable window at a reception venue is to have LED lights around its perimeter, but not along the bottom of the window. Around its perimeter, but not along the bottom of the window. A gable window at reception venues have LED lights around its perimeter, but not along the bottom of the window. Okay, the window is 2.5 meters wide, and the height of the room is 2 meters. The height of the gable is 1, as shown in the diagram. Calculate the length of LED lights nearest needed to 2 decimal places. Right, so what we're asking for then is we're going to have the perimeter, or we're going to have our gable lights here. It said they're not going to go along the bottom. So I need that length, I need that length, I need that length, and I need that length. Right, well, we know that this length here is 2. I've got a lisp for some reason. We know that's 2. So we know that length there, and we know that length there. But we've got a bit of an issue. We don't know that slanted length there, do we? I wonder if there was a topic area we've done before that might help us. Well, if I cut this along here, that is a triangle, but it's not a right angle triangle. But if I cut this down the middle here, I suddenly get a right angle triangle. And I know that that length there is 1. Oh, try that one again. I know that the height is 1. How do we know the height is 1? Because they're telling me here the height is 1. So that's 1. Do I know this bit here? Well, I know that whole length is 2.5. I know that's halfway along. So this length here is going to be half of 2.5, which is 1.25. Rightio, we can use my Pythagoras theorem to tell me that x squared is going to be 1 squared plus 1.25 squared. So x squared is going to do, I'm going to do it on my calculator. You guys should be able to do that. 1 plus 1.25. Sorry, guys. Times 1.25 gives me 2.5625. Take the square root of both sides. And again, there is a video on this, guys, if you don't know what I'm talking about. Gives me 1 decimal place of 1.6 meters. Awesome. Well, that's nice. So we now know that that length there is 1.6 and that length there is also going to be 1.6. So therefore, for part A, my perimeter is going to be 2 plus 1.6 plus 1.6 plus 2, which is going to give me 7.2 meters. Now again, the question was quite clear. We wanted that length, which is 2 plus 1.6 plus 1.6 plus 2. It said it was not going to go along the bottom of the window, so we didn't do that. The glass in the window needs to be replaced. Find the total area to 2 decimal places. And in this situation here, my area is going to be the area of my quadrilateral. All right, so how do we find the area of my quadrilateral? Well, choose a right angle and multiply the 2 sides that are connected. So it's 2 times 2.5. And I need to add on the area of my triangle. So we need the area of the triangle. So how do we work out the area of the triangle? Well, we know it's base times height and halve it. Now we know the base length is 2.5. So I'm going to do 2.5 times its height of 1 times 0.5. And there we go. So putting that into my calculator. 2 times 2.5 is 5. Add on 2.5 times 1 times 0.5 gives me 6.25 meters. Nope, meters squared, because we are in area. Right, then we get to circles. I love circles. Right, again, lots of people know this, but just make sure you are aware that the area of a circle is given by pi, which is a button on my calculator. So if I bring up my calculator, here is my pi button down here. All right, so there's my pi button down there, and you'll notice it comes up. For the ClassPad users, you guys are really lucky because I think you have a separate pi button. Why do we not have a pi button on its own? But anyway, right, that's it. Where are we? So the area is given by pi r squared. The circumference is given by either 2 times pi times the radius or pi times d, where d is the diameter. And again, the radius is from the center to the edge. The diameter is from one edge to the rest. The next, passing through the center. Ooh, I love, 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 love. Right, find the circumference and area of a circle. I don't know why we call it circumference when really it's actually perimeter. But obviously someone out there, Barry, hates us. And so circumference and area of a circle. Right, well, circumference is given by 2 times pi times the radius. 2 times pi. Do I know the radius? It's 3.8. Fire up, Kaz. 2 times pi times my radius. What did it say my radius was? 3.8. Hit enter, and it wants it to 1 decimal place. So my circumference is 23 point, what did it say? 1 decimal place, 0.9. And again, if you are not sure how to do this, I have a video on rounding. Please make sure. My area is given by, I'll leave my calculator there, pi times the radius squared, which is pi times 3.8 squared, which gives me, now again, let's do that on my calculator, pi times, oh, he says doing plus, times 3.8. Now, if you don't know where your squared button is, you can either hit the x squared there, or there's this little caret thing I'll talk to you about later. And again, to 1 decimal place gives me 45.4, start my calculator off, centimeters. And because it's area squared. Whoa. And again, if I had a, what if I was given a hemisphere? If I was given a hemisphere and I wanted to find the area, I basically find the area of a whole circle and then halve it. But you need to be very careful with perimeter, because you would find the circumference of the whole circle and halve it. But when you do that, you only have this outside bit here. You would then have to add on the diameter, and that tricks a lot of people. I mean, a lot of people, which is why we use it in exam questions. Whoo, believe it or not, guys, that's the end of this video. Thank you very much for watching. There's a lot of content. Now go out and practice. My name's Darren from Maths Guru. Please subscribe to my YouTube channel. Again, sounds very needy, but it just lets me know that you're watching. Let your mates know, let your teachers know if you find this video helpful. All of my videos, hopefully, are pretty much the same and pretty good, and a replacement for some of the stuff out there that's way, way, way more expensive. Mathsguru.com, downloadable notes. There are more videos in this series coming. Hopefully, I'll see you in one of those. If not, take care and stay safe.